For those of you at home, if you're watching this, I've noticed the number of people watching is dropping like crazy. But anyways, if you're watching this, we just went over that. You can write that down. Your book has a pretty long process on these. It's way, way longer than this. But this is about as simple as it gets. Always some hiccups. Need to drink something quick. What's wrong with you? Usually if you can change your breathing pattern, hiccups disappear. It works on a baby. Babies ever got the hiccups, you just stick a bottle in that mouth. Those hiccups go right away as soon as they start drinking. It's worked on my two anyways. That's probably the most useful thing from today's lesson that you guys will ever need to know. Anyways, let's talk about the asymptotes. Does it have a horizontal asymptote? There's only two situations for horizontal. Is the degree of the denominator higher than the degree of the numerator? Yes, that's the first case. What's the horizontal asymptote? Y equals 0. Find those vertical asymptotes. I probably want to factor. Factoring makes it way more obvious. X minus 1 doesn't factor. How does x squared minus 4 factor? X plus 2 and x minus 2. Now, are you going to be able to cancel out either x plus 2 or x minus 2? No. So there's no holes in this graph. Those represent pure vertical asymptotes. So your vertical asymptotes are at x equals 2 or x equals negative 2. Does it have a slant asymptote? Oblique? There is none. Because the denominator is less, it's got to be one higher. So there's a slant asymptote. Talk about the zeros. I was talking about this, but nobody was answering. 0 divided by 10. 0. 0 over 50. 0 over negative 1/5. So 0 divided by anything is still what? That's why I was telling you, find zeros by setting the numerator equal to what? 0, because it doesn't matter what the denominator is, does it? No, it only matters what the numerator is. The numerator has to be a 0. So we set the numerator equal to 0. We say x minus 1 equals 0. And we have a 0 where? 1. And I think that just about covers it. I think next we'll want to make a table, but I am going to plot what I have. So that'll help me make the table. You guys probably have lots of free space somewhere on that page. I'm going to graph what I know of. I have a horizontal asymptote at y equals 0. My kids don't like to draw these in. I guess well, my T84 doesn't do it, so I'm not going to do it. Whatever. We have two verticals. Notice I'm labeling them. X equals negative 2 and positive 2. And we have only one known 0. It was at 1. That's the information we have. Now, as far as making tables go, you just need to make tables with values of things you're curious about. The asymptotes are kind of special. When you look at a calculator on asymptotes, you saw these things get really close on either side, didn't you? Like it could go like this and then come back down and then up and then back down. You're going to need to plug in numbers that are really, really close to these asymptotes to see what kind of behavior is happening. Those asymptotes were at plus or minus 2. So what I'm going to do is I'm going to plug in like negative 1.99 and 2.01. Sorry, negative 2.01. Because those are close to the asymptotes. I'll put a little note here as to why I'm doing that. The other one was a positive 2. So I'll do 1.99 and positive 2.01. These are close to the asymptotes. They're going to tell me what's going on there. Am I up high? Am I down low? And I'll use the storage feature on the calculator to do it. Of course, you type that function in, be careful, parentheses x minus 1, divided by parentheses x squared minus 4. So I got like almost 75. For a freehand graph, it's not really going to matter how close you get. And negative 75. Is that negative 25 or so? Negative 25 close enough. The other one's probably 25. That's the way this stuff usually works. All right, I'm going to throw that on the graph and see what else I might be curious about. Negative 1.99 was high, negative 2.01 was low. One of these guys was up high, and one of these guys was down low. I should use a different color. One of them was up high, one of them was down low. 1.99 was low, 2.01 was high. What else might you be interested in finding? I'd be curious about something down here. Maybe the left of an asymptote, maybe the stuff in the middle, maybe stuff to the right. So I'm going to find negative 3. I don't think I'll worry about negative 4. We'll talk about that in a second. Negative 1, 0, and then positive 3. Negative 3, negative 1, 0, and 3. Look at that big table, kids. Now, the rest of the drawing is going to come from what you think is going to happen. Hopefully, it's going to drop in. -3, I don't know how close to 0 it's going to be, but it should be getting somewhere closer to 0. It may not be all the way to the x-axis yet. -0.8. There's 2/3. Here's my y-intercept. Quarter. 3 is hopefully getting close to the x-axis as well. 0.4. And I'm also going to do -3 and 4 just so you can kind of see what's happening. Was -0.41. Why did I do 3 twice? I thought you were over those things. The hiccups work. Hiccups is something I noticed as I got older. They kind of go away.
I don't know why, like the past week.
Maddox fact checked me because I thought as you got older you just had fewer and fewer hiccups. And Maddox Milton had to fact check me, and she's like, no, because she likes to fact check me. But with me, they went away as I got older. I couldn't tell you last time I had hiccups. So that was fun. We made a big old table. Truth is, I'm not going to pay much attention to most of that table. Let's see, -3 was -8/10. I guess maybe this was supposed to be -4 and I wrote -3. Yeah, okay, so -4 was -4/10.
-3 was -8/10. -4 was -4/10. What happens is this thing comes up and down low. And isn't there a horizontal asymptote there? It spends the rest of its life getting closer to it. That's all that happens. What was the value at -1? Was it 2/3? So at -1, we got a y value of +2/3. And we can kind of see based on our points that we have, this thing kind of makes almost a -x³ appearance in the middle. 3, what do we have? Point 3/4. What was it? 0.4. Well, I don't even know that you need the rest of these things. What's it going to spend the rest of its life doing? Is it going to be able to cross this horizontal asymptote right here? Maybe, maybe not, but it's going to get closer and closer and closer to it. It's going to come in from up high and level out. So really the only kind of new skill as far as making a table is just find x values that are really close to your asymptotes. You don't have to do anything else. They're really not that hard. And we only have one more in our notes, and it's a dude with a hole. I don't think I'm going to graph it with you, but we're just going to analyze it. And if you want to graph it, you can graph it on your own time, or you can, do your homework. There's lots of graphing practice in there. Analyze the graph of this thing. I guess we ought to factor it first. How's 2x squared minus 5x plus 2 factor? What's it take to make 2x squared? 2x and x. That's where you start, kids. Factors of 2 are 1 and 2. The goal is to add up to -5. Does the 1 go in the first set or the second set? First set. 2 in the second. That'd be 1x. The outside make 4x. Both of them have to be what? Negative. How's x squared minus 4 factor? X plus 2 and x minus 2. All right. Anything you can throw out the window? It's going. That tells you there's a hole. Where is the hole? And x equals 2. Vertical asymptote is that remaining division of 0 piece. Where is it? X equals -2. This thing does have a horizontal asymptote. Focus on 2x squared over x squared. The degree of the denominator matches the degree of the numerator. Where is a horizontal asymptote? -2. I mentioned this the other day. If you have a horizontal, do you have a slant? No. You do not have a slant. If you have a slant, the degree of the numerator has to be 1 higher than the denominator. There's no slant. Zeros. We factored the numerator. Just set it equal to 0. Where does this thing cross the x-axis? Just do what it says. No other questions. Where?
1/2.
That last guy's special. When we draw that intersection, we won't do a solid point. What will we do? Circle. Open hole. It's an open circle. Because what is there? A hole. Now we know the difference between ass and a hole in the ground. I'm sorry, I said that wrong. No difference between your ass and a hole in the ground, right? But you know the difference between an ass and a hole in a giraffe? I really don't want to draft this one, but it does have a hole. Open hole at 2. What's the other asymptote at? -2? What's the horizontal asymptote at? 2? I really don't want to spend much time doing this, but I do want to talk about values of x that you might understand. I'm not going to make a table to do this. Over here, what would you be worried about? Something close, right? I think I'm hearing Daniel say maybe -2.01. That's what I always do. I just go up to 100. Something to the right of that asymptote? One point 99. Go with it. That's what I'm telling you to use. Say 100th of a unit to it, because that'll give you what you need. And then maybe something like a -3. Just a little bit to the left, so you can see what it's doing. Anything in the middle you care about? If you cared about this section? Maybe those guys? -1, 0, and 1. And maybe something after that hole, which might be what? 3. Just fill in a missing space, kids. That's all there is to it. And I'm not gonna spend time plugging in because I want us to be able to build one, which is the last thing in your notes.
Look at a graph and come up with a function. That's all you gotta do. Now, where are your zeros? -2, by the way, is a touch, and 5 is a cross. I don't know if you remember those words touch and cross from Algebra 2 or not. They're a big deal. Do you have a horizontal asymptote? That y equals 2. You actually have two vertical asymptotes. X equals -5 and x equals 2.
Now, those vertical asymptotes were created in the denominator when we attempted to do what? Divided by 0. They're really easy to create. What factor creates x equals -5? That's plus 5. What factor creates x equals 2? That's -2. That's your vertical asymptote stuff right there. Zeros are created where? In the numerator. What factor creates x equals -2? X minus 2. What factor creates x equals 5? That should be a plus 2. What factor creates x equals 5? It's minus 5. There's actually a little bit more to this one, but I'm not going to try and confuse you on it. Now, if we were to do some near math, x times x is x squared, x times x is x squared. So we have an x squared over an x squared, which means that we would simplify to get a horizontal asymptote. Our horizontal asymptote is at y equals 2. What else needs to be up top in the numerator? 2. To have a horizontal asymptote of y equals 2, we need a 2 up here, because we need 2x squared over x squared. That's kind of how that works. As long as you drop the horizontal asymptote number right in front of the thing up top in the numerator, and you've got it. And let's see if what we wrote makes sense. We wrote that equation. Does it say that we have vertical asymptotes at -5 and 2? Yeah. Does it say the zeros are -2 and 5? Yeah. Does it say the horizontal asymptote is y equals 2? That's it. That's how you write an equation from a graph, kids. That is it.